Hey guys, what is up? Welcome to Radical Academy. In this video, we'll be looking at integration as also the second part of calculus. So some of you who followed me, or some of you have been following me, yesterday we uploaded a video also on calculus where we did a bit of revision about differentiation. Okay, so before you get to what is called integration, first of all, you must be able to understand what is differentiation. Okay. So as we all know, calculus normally deals with the rate of change, okay, with respect to something, okay. So in this video specifically, we'll be looking at what is integration, okay. So if you really understand, if you did understand the previous video, which is up there on our YouTube channel, you can also go and check it out before you watch this video about integration. So now, what is integration? So integration is simply the opposite of differentiation. So when you are given a certain equation in form of y as a subjective formula, and you are told to say, can you differentiate this, okay? And then if you have a differentiated equation or function, then the question can also ask you the opposite of that. Can you integrate this function or this equation? So now, follow me as I walk you through in this video specifically on integration. So if I have y equals to x squared. Now, the most basic idea about integration is first of all to understand what is differentiation. So let's say, for example, if they tell me to say, can you differentiate this one, okay? Can you differentiate this one, okay? So when you're differentiating, first of all, the symbol is dy dx, okay? So dy dx simply means that differentiate this one with respect to x, okay? So you're going to say, whenever you're differentiating something like this one, this power normally is going to multiply with the coefficient, the number in front of x, okay? So now there is no number there, so it's going to be 2 multiplied by 1. So now, since there is no number, what you do is you just say the power multiplied by the coefficient of that variable, which is x, okay? Now, in this specific example, we don't have any coefficient in front of x, meaning that there is just an invisible 1, which you cannot see because 1 times x is x. So there is an assumption that there is just x there. So 2 times that 1 multiplied by x. Now this power is going to reduce by 1. Okay. So therefore, dy dx equals to 2x, and 2 minus 1 is just 1. And this is going to be, okay, this is now going to be dy dx equals to, now this will be, the power is 1. So now anything raised to the power 1 is that thing, okay? So if you have 1,000 raised to the power 1, I'm just going to actually get 1,000. If you have got, let's say, for example, 10 to the power 1, I'm just going to get 1. That's 10. So anything raised to the power 1 is that thing, okay? So we are going to say it's just going to be 2x. Now, once you have a differentiated answer like this equation which says y equals to x squared. So the differentiated gives us 2x. Now, if I want to get back from this, okay, from this back to this one, okay. So now integration is a reverse process or the reverse of differentiation. So if you have a differentiated function or equation, then if I want to get back to the original equation, then I actually use the idea of integration. So integration is the reverse of differentiation. Okay, so I hope that is clear. So when I want to get to that point, from this point all the way to that, so okay, so integration is from differential back to the original given equation. Okay, so now after you do that, after you have differentiated the equation, or rather even just a function, the next thing that you're supposed to do is actually to integrate. Okay, now I've mentioned that integration is the reverse of differentiation, and every function that you have or any equation that is of high power, like degree x to the power 3, x to the power 2, those powers, when you are differentiating, the powers reduces by 1, and now when you are integrating, the powers actually increases by 1, because we want to actually get to that same original function or equation. So now you can see from here now that we have this y equals to x squared, and we have now the differentiated equation as dy dx equals to 2x. Okay. Now, how do we get from this 2x dy dx equals to 2x, dy dx equals 2x, back to this original function? Okay, so I'm going to keep it very simple and very straightforward. Okay, so we are saying if dy dx equals to 2, find y. Okay, so all we are saying is find y, this y, which is x squared. Okay, which is x squared. Now the next thing that you're supposed to do is you say y, okay, is going to be, so we know that there is a power 1 there, okay, there's a power 1 there that we don't see. And what you do now is the power will increase by 1, okay, so I'm going to say 2x 1 plus 1, okay, and this power, okay, you bring it down as 1 plus 1 also. Now, the moment you do that now is you are almost there, okay? So you say, therefore, y equals to 2x plus 2 over 2 plus c. Now, this c simply means constant, okay? The c simply means it is a constant. Now, why are we adding the c is, I'm not going to go into the details, but to summarize why we're adding the c is because we are looking at this integration as more like an equation that passes over either x or y. So we don't know where this equation passes over or passes through when you graph the points on a graph paper. We don't know where this equation specifically passes through on any of the points, either x or y. Okay, but the most important thing is that the constant value tells you, okay, a point on a graph paper where that equation passes through. So the fact that we don't know that, we are going to assume that we can actually assign the constant any number. Okay, it can be k, it can be any number of our choice. But when you look at C kind of resembles so much of what we are talking about, the constant. Okay, so now once you do that, then you can simply say y, then this and this goes. So x to the power 2 plus c. Okay. So that's the final answer. That's the final answer. Okay. Okay. So now there, what you've just done is we have integrated, okay, this equation, okay, back to the original one, which is this one. Okay. So you can just kind of ignore the c. Now, the last point I want to make is to understand the symbol of integration. So it's kind of an S, an elongated S, okay? So now this, okay, can be just like, oh, okay. So that symbol there. So integrate this one to x dx. Okay. Now integrate this 2x with respect to x. So now we are saying that can you integrate that to x with respect to x? So the symbol kind of an elongated S is normally referred to as an integral, okay? Or rather simply reads as integration, okay? So the final answer is what we call the integral of this one. So then the answer for this one was x squared, okay? So it was x squared. And this simply means you can just add the c. Okay. So now you always need to add a c, which I've actually explained, which is the constant. Because we are looking at the points at which the graph, obviously, this equation is going to pass on the y-axis. Okay. So thank you so much, guys, for watching. Make sure that if you have not subscribed to the channel, be able to subscribe now so that you'll be able to receive all our updates and all our posts on either YouTube, Facebook, and also TikTok. So make sure you do understand the concept of what integration is. So it's bye-bye. My name is Mike, and this is Radko Academy. Thank you so much.